This lecture is going to be straightforward. It is about energy stored in a capacitor. Make sure you achieve these objectives by the end of this lecture. So as you've seen earlier, we have a capacitor here and a battery that is charging the capacitor. If the capacitor is charged, then one terminal plate will be positively charged. That means it will be at a higher potential. Then the other plate, which is negatively charged, will be at a lower potential. And for this reason, there will be potential difference across the two plates. What it means is that energy will be lost if we move electrons from here to the other plate, from a low potential to a high potential. Then the electrons will lose energy. As it is now, when the electrons are still where they are, the capacitor is storing energy. The energy being stored by the capacitor came from the battery initially. The battery pulled electrons from this plate and caused this setup or separation of charges in the capacitor. So we say the battery has given its energy to the capacitor. After charging the capacitor, the battery can be removed and the energy will still be stored in the capacitor. Yes, so if for any process or any method we are able to move the electrons from here, from this lower potential to this high potential, then that energy will be released. Let's see one way this can happen. So we can now connect a resistor across the capacitor so that the electrons will get a path to flow to the other side. If we're able to set up this experiment, electrons will flow from lower potential to higher potential. Indeed, the electrostatic force of attraction will be between the positive charges here and then the negative charges here. The other thing you need to know is that the electrons cannot jump across this gap and come and neutralize these charges here. They rather have to find this path, which is a conductor, and there are other free electrons there. Then they will move through the resistor before getting to the high potential region. By so doing, they will lose their energies to the resistor. That is evident in testing the temperature of the resistor after the electrons have flowed. You realize that it will be a little bit higher than before. That means the electrons have lost energy to the resistor, making the resistor warm. So all these are evidence that the capacitor stored the electrical energy that was when it was connected to the electricity, the cells. When it was connected to the cells, then after it has been connected to the resistor, it lost the energy to the resistor, making the resistor a little bit warm. So these are the explanation to the reason why we say capacitors store up energy. Now let's come to the mathematical way of calculating this energy stored in the capacitor. The energy stored in the capacitor depends on any two of these quantities. That's the quantity of charge stored in the capacitor, the capacitance itself, and the voltage across the capacitor. We are not going to derive it. You simply need to keep this one at your fingertips, and then you can rearrange it in some other way. The energy stored in the capacitor is equal to the square of the charges accumulated on the plates divided by 2 times the capacitance. If you keep this equation at your fingertips, you are able to handle it well. Then these ones will be easy for you. You just have to remember that the quantity of charge on a capacitor plate is equal to the product of the capacitance and the voltage voltage across it. Then you can substitute the quantity of charge into the equation. Then you derive some of these ones. I want you to prove these ones yourself. Make sure you prove them. It will help you. There will be other questions that will help you use these equations, either of these equations, and that will make you better students. Okay, I'll do a separate video to demonstrate to you how to handle the equations, the mathematical equations we've encountered so far. So don't worry about examples now. The last thing I would like to talk to you about is some applications of capacitor. At this point, you need to know the first two. Make sure you are able to explain why it can be used as a battery, simply because it can store energy. And this lecture has explained why we see capacitors store up energy. Then it does block direct current. In some applications, we simply want only changing current to flow. And if we want only changing current to flow, it's the capacitor that we use, because capacitors will not allow direct current to flow, current that is flowing in one direction. So because when charges get to one plate, it will block them, and if more charges get to that plate, it will not allow any more to go through, which means direct current has been blocked. So just find out more about these two applications of capacitors. In next semester, if I happen to handle you, we are going to talk about capacitors being used as oscillators for smoothing, how do we call it, for smoothing rectified signal, or if we have an AC and we want to rectify it. After rectifying, we smoothen it and we use capacitors. And we can also use them for as filters. All these ones will be handled in the next semester. We can't talk about them now, but for now, make sure you know these ones. It's examinable. Thank you.